Hey everyone, and welcome to a deep dive into the world of object-oriented design patterns.
Right.
We're going to be using excerpts from the book.
Yeah.
Design patterns.
Yeah.
Elements of reusable object-oriented software.
A classic.
A classic in the field.
Right.
You might be a seasoned developer or just starting to explore these concepts.
Yeah.
But either way, consider this like your cheat sheet to design mastery.
Yeah.
So think of it like this.
Okay.
If you're building a house,
Yeah.
you wouldn't just start from scratch every time.
Right.
You'd use blueprints.
Right.
Blueprints, yes.
Well, design patterns are kind of like blueprints for software.
That's a great analogy. And this book acts as a catalog of 23 such blueprints,
Oh, wow.
each addressing recurring design problems in object-oriented software.
Mm.
And it even uses a real-world example, a document editor called Lexi,
Oh, cool.
to show how these patterns come alive in a real application.
Right. I love that they use Lexi because it makes these concepts way more tangible.
Like, how does Lexi handle things like text formatting, different look and feel preferences, or even the undo-redo function?
Yeah.
I bet there are some clever patterns at play there.
Absolutely.
But before we get lost in Lexi's world, can you give us like a clear definition of what these design patterns actually are?
Absolutely. The book defines a design pattern as, and I quote,
Okay.
a design pattern names abstracts and identifies the key aspects of a common design structure that make it useful for creating a reusable object-oriented design.
Okay.
Essentially, they are a way to bottle up proven solutions to common design problems, so you don't have to reinvent the wheel every time.
Okay, so they're like pre-packaged solutions to common coding dilemmas.
Exactly.
It's like having a library of best practices, right?
Exactly. And what's fascinating is that they go beyond just providing a solution.
Okay.
They also give you a shared language to communicate these solutions with other developers. It's just like having a secret handshake for software architects.
I like that, a secret handshake. So it's not just about writing better code, it's also about communicating more effectively about design.
Absolutely. And one of the most famous design patterns, which you might already be familiar with, is the Model View Controller Pattern, or MVC.
Right.
The book uses an example from Smalltalk to illustrate it.
Right. MVC, that's a big one, especially for web development.
Yeah.
So remind me, how does MVC use the observer pattern?
Okay.
I always get a little fuzzy on that part.
Well, the observer pattern allows the view and the model to stay in sync
Okay.
without being directly coupled. So when the model changes,
Right.
the view automatically gets updated and vice versa.
Right.
It's like a chain reaction, but in a good way.
So instead of the view constantly asking the model, like, hey, did anything change?
Right.
The observer pattern lets the model proactively notify the view, hey, I've got an update for you.
Precisely.
Yeah.
And this decoupling is a key principle in object-oriented design, which the book emphasizes heavily. They talk about programming to an interface, not an implementation. What are your thoughts on that?
Well, I remember struggling with a design problem a while back.
Okay.
And I was trying to force a square peg into a round hole by relying too heavily on inheritance.
I see.
And then it hit me.
Yeah.
I could use the strategy pattern.
Uh-huh.
It was like finding the perfect wrench for the job.
Ah, yes. Those aha moments are the best, aren't they?
They are.
The strategy pattern is a brilliant way to swap out different algorithms or behaviors at runtime.
Exactly. And it all comes back to that idea of programming to an interface.
Right.
Instead of hard coding a specific implementation,
Yeah.
you define an interface that multiple implementations can adhere to.
Yeah.
That gives you so much flexibility.
Right. And another key principle the book highlights is favoring object composition over class inheritance.
Okay.
It uses Lexi to demonstrate this, showing how composition can make adding new features much smoother.
Composition over inheritance. That's one I'm still wrapping my head around.
Okay.
Doesn't inheritance promote code reuse? Why would you want to favor composition?
That's a great question. And it's a point of much debate in the software world.
Yeah.
While inheritance does offer code reuse,
Right.
overusing it can lead to what we call the fragile base class problem.
Okay.
If you change something in a parent class,
Right.
it can break things in the child classes in unexpected ways.
Oh.
It's like building a house of cards, one wrong move, and the whole thing collapses.
Yikes. Okay. I'm starting to see the appeal of composition now.
Yeah.
So it's about building objects by combining smaller, more manageable pieces,
Right.
rather than relying on a deep and potentially fragile inheritance hierarchy.
Exactly. It's a more modular approach.
Okay.
And this leads us nicely into the different categories of design patterns,
Okay.
starting with creational patterns, which, as the name suggests, deal with the creation of objects.
Ah, yes, creational patterns.
Yeah.
These are the ones that help us avoid those messy constructor calls and tangled dependencies.
Absolutely. And the book dives into some really interesting ones,
Okay.
like the abstract factory pattern.
Hmm.
They use a maze game example
Okay.
to show how it can create families of related objects without specifying their concrete classes.
Okay. So the abstract factory is like a master builder that knows how to create all the different parts of a maze.
Yeah.
Walls, doors, rooms.
Right.
Without needing to know the specifics of each individual component.
Precisely. It's about creating objects in a consistent and flexible way.
Okay.
And then we have the singleton pattern,
Right.
which ensures that you only have one instance of a particular object.
Right. The singleton, I've heard it can be a bit of a double-edged sword.
Yeah.
What are your thoughts on that?
Well, it's true.
Yeah.
While the singleton can be useful for managing resources or providing global access points,
Okay.
it can sometimes lead to tight coupling, making your code harder to test and modify.
Yeah.
It's like having a single global light switch for your entire house.
Okay.
Convenient at first, but a nightmare if it breaks.
That's a good point. It's like anything powerful, you have to use it wisely. And what about the prototype pattern?
Okay.
I'm particularly interested in that one because I'm dabbling in game development.
Yeah.
And I can see how it could be useful for cloning game objects.
Absolutely. The prototype pattern is perfect for scenarios where creating objects from scratch is expensive or complex. It lets you create new objects by copying existing ones,
Okay.
which can be much more efficient.
So instead of writing a ton of code to create each new enemy in a game,
Right.
you could just clone an existing enemy and tweak its properties.
Exactly.
That's pretty slick.
And that's the beauty of creational patterns.
Yeah.
They offer elegant solutions to a variety of object creation challenges.
But before we go too deep into specific patterns,
Okay.
let's move on to structural patterns,
Okay.
which deal with how objects are composed and related to each other.
Right.
Remember Lexi, our trusty document editor?
Of course.
Yes. How could I forget Lexi? I'm still curious about how it handles different look and feel preferences
Okay.
without turning into a spaghetti code monster.
That's where structural patterns shine.
Okay.
Lexi uses several of them to achieve this flexibility and maintainability.
Okay.
But one of the key players is the decorator pattern.
Okay.
It's a clever way to add responsibilities to objects dynamically without modifying their core structure.
Okay. The decorator pattern. So is it like adding accessories to a car
Yeah.
without changing the car itself?
Yeah.
Like you could add a spoiler or a fancy paint job without messing with the engine?
That's a perfect analogy.
Okay.
For example, imagine you have a simple text view in Lexi.
Okay.
With the decorator pattern, you could add a border around it
Okay.
or make it scrollable without modifying the text view's core code.
Ah, that makes sense. So it's like layering on features without making the core object more complex.
Precisely. And the book also mentions the bridge pattern,
Okay.
which is another powerful structural pattern that Lexi uses.
Right. The bridge pattern, that one always sounds a bit mysterious to me.
Okay.
What's the key idea behind it?
The bridge pattern is all about separating an abstraction from its implementation,
Okay.
allowing them to evolve independently. It's like building a bridge between two sides of a river.
Okay.
The bridge itself provides a way to cross,
Right.
but the details of how the bridge is built are hidden from the people using it.
Okay. I'm starting to get it to picture.
Yeah.
So in Lexi, the bridge pattern could be used to separate the concept of a window
Right.
from the specific implementation of that window on different operating systems like Windows or Mac.
Exactly that way. Lexi's core code doesn't need to know anything about the specifics of each windowing system. It just interacts with the bridge, which handles the underlying details. This makes Lexi much more adaptable and portable.
That's really clever. So structural patterns are all about building flexible and maintainable relationships between objects.
Precisely.
It's about creating a solid architecture for your software.
Precisely. And that brings us to our final category of design patterns.
Okay.
Behavioral patterns. These patterns deal with the way objects communicate and interact with each other.
Ah, yes. Behavioral patterns. These are the ones that help us define how objects collaborate and fulfill their responsibilities.
Exactly. And some of the key players in this category are the command pattern,
Oh, okay.
the iterator pattern,
Okay.
and of course the observer pattern, which we discussed earlier
Yeah.
in the context of MVC.
Right. It seems like the observer pattern pops up everywhere.
Yeah, that's a very common one.
But before we dive into specific behavioral patterns, let's take a quick break.
Okay.
When we come back, we'll explore how these patterns are used in Lexi and in other real-world applications.
Sounds good.
Welcome back. So we've covered the three main categories of design patterns: creational, structural, and behavioral.
Right.
Now I'm really itching to see these patterns in action, especially in Lexi.
Of course, let's delve deeper into Lexi's world
Okay.
and see how these patterns are actually implemented.
Perfect. Remember how we were talking about Lexi handling text formatting?
Yeah.
Like breaking it into lines and columns, dealing with margins? Right.
All those little details that can make code a nightmare.
Yes, formatting is a classic design challenge. And it's where the strategy pattern really shines.
Okay, the strategy pattern.
Yeah.
Remind me how that works again?
Well, imagine you have a toolbox
Okay.
full of different tools, each designed for a specific task.
Okay.
That's essentially what the strategy pattern does. It encapsulates different algorithms or behaviors as separate objects called strategies.
So in Lexi's case, each strategy would be a different formatting algorithm.
Exactly. Lexi might have a simple compositor strategy.
Okay.
For basic line breaking, a text compositor.
Good.
For handling complex mathematical formulas and so on.
Ah, I see. So instead of having one giant formatting function with a million if-else statements,
Right.
Lexi can just pick and choose the right strategy for the job.
Precisely. And this makes Lexi's formatting incredibly flexible.
Okay.
You can easily add new formatting algorithms without modifying Lexi's core code.
That's a huge win for maintainability. It's like having a plug-in system for formatting. Exactly. And this adaptability extends to other areas of Lexi's design.
Okay.
Remember how we talked about supporting multiple look and feel standards?
Yes.
Like Windows, Mac, or even a web-based interface?
Yes. That was another mind-boggling challenge. How does Lexi handle that without ending up with a tangled mess of platform-specific code?
Well, that's where the abstract factory pattern comes in.
Okay.
It's like having a master blueprint
Okay.
for creating families of related objects,
Okay.
but without specifying their concrete classes.
Okay. I'm intrigued, but I need a bit more explanation. What do you mean by families of related objects?
Think of all the different user interface elements in Lexi.
Okay.
Buttons, scroll bars, text fields, menus, and so on.
Right.
These elements can have different appearances depending on the look and feel you're going for.
Right. So a family of objects would be like all the buttons, but with different styles to match different platforms.
Exactly. And the abstract factory pattern provides a way to create these families
Okay.
without coupling your code to specific implementations.
Okay, so how does that actually work in practice?
Let's say Lexi needs to create a button.
Okay.
Instead of directly instantiating a Windows button or a Mac button,
Okay.
it uses an abstract factory object
Okay.
to do the creation for it.
So the abstract factory acts like a widget factory. It knows how to create buttons, scroll bars, and other UI elements in a consistent style, but it doesn't care about the specific platform.
You got it.
Okay.
And Lexi can be configured with a different abstract factory,
Okay.
depending on the desired look and feel.
So if you want Lexi to have a Mac look and feel, you just give it a Mac abstract factory.
Right.
And all the widgets it creates will have that style.
Right.
No need to rewrite a bunch of code.
Precisely. The abstract factory pattern keeps things clean, modular, and incredibly adaptable.
I'm starting to see a pattern here. Literally. These patterns are all about making code more flexible, maintainable, and reusable.
Isn't there another pattern that's all about making objects more adaptable, like adding features on the fly?
You're thinking of the decorator pattern?
Oh, yeah. It's a brilliant way to add responsibilities to objects dynamically
Okay.
without modifying their core structure.
Okay, the decorator pattern.
Yeah.
So it's like adding power-ups to a video game character.
Yeah.
You can give them a shield, a speed boost, or double jump without changing the character's fundamental design.
That's a great analogy. And Lexi uses the decorator pattern extensively to enhance its user interface elements.
Okay.
For example, imagine you have a basic text view object in Lexi.
Okay.
With the decorator pattern, you could easily add a border around it, make it scrollable,
Okay.
or even add spell checking functionality.
So the decorator acts like a wrapper around the original object, adding new features without modifying the object itself. It's like putting a gift box around a present. The present stays the same, but you've added an extra layer of presentation.
Exactly. And you can even stack multiple decorators.
Oh!
So you could have a scroll decorator wrapped around a border decorator, which is wrapped around the original text view.
Wow, that's pretty powerful. So from the client's perspective, it's just a text view, whether it has a border scrolling or any other decorations.
Precisely. The decorators are transparent to the client, which keeps things simple and elegant.
This is all starting to click for me now. But I can't help but wonder, when do you actually decide to use these patterns?
Yeah.
I mean, it's one thing to know about them,
Right.
but it's another to recognize when they're the right tool for the job.
That's a great question.
Yeah.
And it's where experience and judgment come in.
Okay.
Often you'll start to notice recurring problems in your designs, or you'll encounter situations where certain patterns seem like a natural fit.
So it's like the more you work with these patterns, the better you get at spotting the telltale signs that they're the right solution. It's like a detective developing a sixth sense for patterns in criminal behavior.
Exactly. And sometimes you might even refactor existing code to
Oh,
incorporate patterns.
yeah.
This can make your code more flexible, maintainable, and reusable.
It sounds like design patterns are like secret weapons in a programmer's arsenal. They can help you conquer complex challenges and write truly elegant code.
Indeed. And the more you learn about them,
Yeah.
the more you'll appreciate their power and versatility.
Now, I'm particularly curious about the bridge pattern.
Okay.
It sounds like a powerful way to decouple an abstraction from its implementation.
It certainly is.
Yeah.
Remember Lexi's challenge of supporting multiple Windows systems, like
Yeah.
Windows and Mac?
Yes. How could I forget that headache? It seemed like an impossible task to support all those different platforms without ending up with a code base that looked like Frankenstein's monster.
Well, the bridge pattern provides an elegant solution.
Okay.
Lexi defines a window class,
Yeah.
which represents the abstract concept of a window,
Okay.
with all the common methods like open, close, draw, and so on.
So the window class is like a blueprint for all Windows, regardless of the underlying operating system.
Exactly. And then Lexi defines a separate hierarchy of window imp classes, each representing a specific Windows system implementation.
So there might be a Windows window imp class, a McWindow imp class, and so on.
Precisely. And the window class holds a reference to a window imp object,
Okay.
which handles the platform-specific details.
So when Lexi needs to draw a window, it just delegates the task to the appropriate window imp object. It's like having a translator for each window system.
You got it.
Oh, okay.
And this separation allows Lexi to work seamlessly with different Windows systems without any code changes.
That's brilliant.
Huh.
It means Lexi's core code doesn't have to be littered with conditional statements to handle different platforms.
Exactly. The bridge pattern keeps things clean, modular, and incredibly adaptable.
Okay, I'm sold on the bridge pattern. But before we get too carried away, let's talk about another challenge Lexi faced. Implementing user operations like undo and redo.
Yes, the magic of making mistakes disappear.
Yeah.
This is where the command pattern comes into play.
Right, the command pattern, it's about encapsulating user actions as objects, right?
Exactly. Each command object knows how to execute a specific action, as well as how to undo it.
So, for example, there might be a cut command object, a paste command object, and so on.
Precisely. And Lexi maintains a history list
Okay.
of executed commands.
Okay, I'm starting to see how this works. To undo an action, Lexi simply takes the last command from the history list and calls its undo method.
You got it. And to redo an action, it takes the next command from the list
Okay.
and calls its execute method.
That's so elegant. It's like having a time machine for user actions.
And that's not just about undo and redo. The command pattern can also be used for logging scripting
Oh, wow.
and other scenarios where you need to manipulate and replay actions.
Wow, my mind is officially blown. These patterns are like little design superheroes, each with its own special powers.
They certainly can be. And the best part is they can work together
Hmm?
to solve even the most complex design challenges.
I'm eager to learn more, especially about how these patterns are used in real-world applications beyond Lexa.
Well, stay tuned, because in the next part of our deep dive, we'll explore some fascinating examples of how design patterns are applied in various domains, from game development to web applications to enterprise software.
Sounds good to me. Welcome back to our deep dive into design patterns. So we've been talking about the three main categories, creational, structural, and behavioral,
Right.
and even saw how they're used in Lexi, which is that document editor example.
Yes, we've seen how these patterns act like these adaptable blueprints,
Right.
fostering this flexibility and maintainability in our software design.
It's like they give us a whole new vocabulary for talking about these design challenges.
Yeah.
But I'm ready for some real-world examples.
Okay.
You know, beyond Lexi's world, how are these patterns being used out in the wild?
Excellent question. Let's step outside Lexi and see how these patterns are tackling real-world challenges across these diverse applications.
Perfect. What comes to mind first?
Well, imagine a scenario where you're dealing with a massive number of objects. Think of like a complex graphical design tool or a sprawling virtual world in a video game.
Okay.
Managing all those objects efficiently could be a real memory hog.
Yikes. That sounds like a recipe for performance nightmares. How do you even begin to tackle that?
That's where the flyweight pattern swoops in to save the day.
Okay.
It's all about sharing objects to conserve memory and boost performance.
Okay, the flyweight pattern. That name always makes me think of something light and agile, which I guess is fitting.
Right.
But remind me, how does it actually work?
The key is understanding the difference between intrinsic and extrinsic state.
Okay.
Intrinsic state is like the core essence of an object, something that's shared across multiple instances.
Okay.
Think of it like the letter A. It's always A,
Right.
regardless of its font size or color.
Right. The A itself is constant, but how it's displayed can change. So that's the extrinsic state.
Precisely. And the flyweight pattern allows us to share those intrinsic states, those unchanging core elements. So instead of creating a separate object for every A in a document, we can have one shared A object. And each instance just stores its own extrinsic state, like its position and formatting.
Ah, that makes sense. So it's like having one master copy of A in the library and everyone just borrows it and adds their own personal notes.
Exactly. And this shared object approach dramatically reduces memory consumption, especially when dealing with thousands or even millions of objects.
That's brilliant. It's like turning a heavy, cumbersome library into a sleek, efficient digital archive. So the flyweight pattern is the superhero of memory management. But what about navigating through all these objects? I'm
Okay.
thinking of those vast data structures that are so common in programming.
You're right. Traversing complex data structures can be tricky.
Yeah.
That's where the iterator pattern steps in, offering a standardized way to move through a collection without exposing its underlying implementation.
Okay, the iterator pattern.
Yeah.
So is it like having a universal remote control for collections?
Yes.
No matter what type of collection you have, a list, an array, a tree, you can use the same interface to navigate it.
Precisely. It's like having a tour guide that knows all the best paths through a complex museum. You don't need to know the layout yourself. You just follow the guide.
That makes a lot of sense. It keeps your code clean and adaptable. You don't have to write separate traversal logic for each type of collection.
Exactly. The iterator pattern abstracts away those implementation details, making your code more readable and less prone to errors. It's a fundamental pattern in object-oriented programming and is widely used in various libraries and frameworks.
It's like a behind-the-scenes organizer, making sure everything flows smoothly. Speaking of organization, there was one last pattern that really caught my eye. One that seemed almost magical. The visitor pattern.
Ah, yes, the visitor pattern. It's a powerful technique for adding new operations to a hierarchy of objects without modifying the classes themselves.
I remember the book describing it as separating an algorithm from the object structure on which it operates. It's like being able to teach an old dog new tricks without actually changing the dog.
That's a great way to put it. Imagine you're building a compiler that needs to generate code for different types of expressions like arithmetic expressions, Boolean expressions, and so on.
Okay.
Each expression type has its own unique structure.
Right, so you'd have different classes for each expression type. But how do you add a new operation like code generation without modifying all those classes?
That's where the visitor pattern comes in. Instead of adding a generate code method to each expression class, you create a separate visitor interface with methods for visiting each expression type.
Okay, so the visitor interface is like a template for operations that can be performed on the expressions.
Exactly. And then you can create concrete visitor classes that implement those operations for specific code generation targets, like Java, Python, or C++.
So you might have a Java code generator visitor, a Python code generator visitor, and so on. And each expression object can accept a visitor and call the appropriate method for that visitor.
Precisely. It's like having a team of specialized mechanics, each capable of working on a specific type of car. The car itself doesn't need to know how to be repaired. It just needs to know how to let the mechanics do their job.
That's incredible. It means the compiler's code generation logic is completely decoupled from the expression hierarchy. It's like having a universal adapter that can plug into any type of expression.
Exactly. The visitor pattern allows you to add new operations without modifying the existing classes, making your code incredibly flexible and extensible.
Wow, this deep dive has been an amazing journey. We've learned how design patterns can act like adaptable blueprints, guiding us toward more robust and maintainable software architectures.
We've seen how these patterns, born from the collective wisdom of experienced developers, can help us tackle common design challenges with elegance and efficiency.
It's like having a secret society of software architects whispering their best-kept secrets in our ears.
And the best part is, this is just the beginning. There's so much more to explore in the world of design patterns.
Exactly. I encourage everyone listening to dive deeper into this book and other resources and to start experimenting with these patterns in your own projects.
Remember, design patterns are not rigid rules, but rather guidelines and tools to be adapted and combined creatively.
They're a testament to the power of shared knowledge and collaboration in the software development community.
And they offer a path toward writing better, more elegant, and more sustainable code.
Well said. Thank you for joining us on this deep dive. We hope you've gained valuable insights and are excited to continue exploring the fascinating world of object-oriented design patterns.
Until next time, happy coding.